So now I'd like to move to a different example. So we've been focusing a lot on that general social survey data, and I gave you a nice table that showed you all the numbers. Sometimes when you do a probability problem, it looks more like this. So it'll be a word problem. It'll say something like, we have this data set, it's got 6,224 people, the year was 1721, these people were exposed to smallpox in Boston, 13.66% of people who were exposed to smallpox died. 3.9% of people were inoculated, like they got a vaccine. 0.1% of people who were inoculated against smallpox died. And what is the probability that an inoculated person died of smallpox? And then we could try to answer this question a couple different ways. So you could use the equation, the P of A given B is A and B over the probability of B. But for most people, it is easier to think about these word problems if they're in table form. So this is how I always begin, is I try to convert to a table. So this problem is nice because it's given you the total number of people. Sometimes they don't give you a total number of people, and then you can just pretend that there were 100 people or 1,000 people or something, and use that to do your multiplications. So let's see, I'm going to try and make myself a little space for a table. And let's put inoculated, and not, and died, and lived, and then we're going to need totals, and we're going to need the grand total. So when you're trying to make a table like this, maybe I'll smoosh it over a little bit, you have to decide where to start. And I usually start down in this bottom corner with the total. Like I said, if it hadn't given you the number, you could just put 1,000 in there, but we're going to start with, we know there were 6,224 people. And then I like to think about the most simple of the percentages that were given to me that doesn't have two things going on. So the one about dying, this 13.66%, that one looks good. And this 3.92% that's just about inoculated, that also looks good. This last one, we're going to save that for last because that's got two things going on. So let's see. The total number of people who died, so we're going to put it here in the table, is 13.66%. So I'm going to do 0.1366 times 6,224, and I got about 850 people. We might need to round a little bit. So I'm going to say 850 people died. Let's see. Then we know that 0.0392% were inoculated, so 6,224. Let's do that multiplication. 244, let's say. And so that's the total for down here, 244. And then we should fill in these other totals. We need to fill in a number here, and we need to fill in a number here. And the way that we're going to do that is by subtracting. We know that there needs to be 6,224 total. So if we subtract off 850, and I'm going to get 5,374. I'll write that here as well so that we can keep track of our work. And then we can do the same thing here. 6,224 minus 244, 5980. 5980. So now we've got all the margins. Sometimes we call these the margins because they're kind of on the edges of the table. And we need some numbers in the middle of the table to be able to fill out the rest of the table. And so that's where this last number comes in, the 0.1%. 0.1% of people were inoculated against smallpox and died. Because that has an and, I can actually just put it into this space. So they died and they were inoculated. And so I can do the same kind of multiplication that I did before. 0.001 times 6,224. That's about 6 people. 6 people here. They died and they were inoculated. And then we can fill in the rest of the table. So I can do 244 minus 6, and that's 338. I can do 850 minus 6, and that's 844. And I can do 5374 minus 338, and that's 5036. Okay, so that was a lot of work to make the table, but now that we've got the table, it should be pretty straightforward to answer any probability question that might be asked of us. So we're going to try and answer this question. What is the probability that an inoculated person died of smallpox? So what's the probability of dying given that we know you were inoculated? And again, I could use that formula, or I could just say, okay, I know that you were inoculated, so I'm just going to stay in that column. So the bottom of my fraction is going to be 244, and 6 of those people died. So that would be 6 out of 244, or 0.025-ish. So 2.5%. 2.5% of people who were inoculated died. All right, so we've been thinking about conditional probabilities. We talked about this formula. The probability of A given B is the probability of A and B over the probability of B, and we can use that. We can just multiply by the probability of B on both sides, and then we get this other rule. So if we want to figure out the probability of two things happening together, and we know a conditional probability, then we could use this rule. And the same thing works if we want to sort of flip the term that we have. So again, these are just some equations. Those can be useful, but a lot of times if you have the table, you don't even need the equation. So let's go back to that smallpox example. What percent of people were not inoculated and lived? Go grab my table from before, and we should be able to just answer this pretty straightforwardly. Not inoculated and lived, not inoculated and lived. That is 5036 divided by 6224, and that's 0.809, so 80.9%. And we definitely could have used our probability rules to answer this question as well. But I think that it would have been a lot more challenging. So if you'd like to, you could try using the multiplicative rule. I'm happy to talk with you about your approach when we have synchronous class.